Hello everyone, welcome to summer internship program, and in my previous video practice we have learned how to perform trigonometric leveling, simple leveling. So from now we will learn how to do inverted stuff leveling. This leveling techniques is used to obtain heights points above the line of sight. This is our leveling instrument, and this is our line of sight, or we can call line of collimation. And this is above points, and this is the below points. Okay? And if the points is below from the line of sight, so we can use simple leveling techniques. If the points is above the line of sight, we use inverted stuff level. Usually in inverted stuff method is in practice is used to measure the heights of the room. Just imagine this is the ceiling or slab, this is the floor. And if we want to identify the height of the room, this is the height of the room, we install the leveling instrument in between point A and B, and this is the floor. Point A located in the floor and B in the ceilings, and point B is, you see, it's a higher than line of sight, the line of the collimations. This is here. This is the line of sight. This is the line of sight or collimation. What we do, we install the leveling instruments and take the first measurement from the leveling rod R1, and bring the rod to the B, but here we have to invert our leveling instrument, leveling rod upside down. It means it's 0 is started from here, okay? But in here, point A, it's 0 of the leveling rod is started from the point A. In this way, we calculate, we determine the height of the room. By adding the two measurements of the leveling instruments. In leveling inverted stuff method is also used to identify the heights under the bridge. Just imagine this is the bridge, under the bridge, and this is the terrain, irregular terrain. If we want to identify the heights between point A and B, so at point B is of course above the line of sight. This is the line of sight or line of collimation. So we use inverted stuff method. So we install our leveling instrument in half distance between point A and B. We take the first measurement from this leveling rod and rotate the leveling instrument toward to point B and place the leveling rod upside down, and upside down is 0 is started from point B. Then we take the R2 measurement and height, relative height, point A, point B is equal R plus R2. Okay, so usually we measure the height of the bridge, during the traversing or during the after the natural disasters, for example, after the earthquake or after the flooding, just to assess the displacement of the bridges after the earthquake or after the flooding, respecting to our reference point. So A could be our reference point. So this is the bridge. Okay. So in a practical point of view, we have no bridge in our laboratory, but I can demonstrate you how to use inverted staff method to identify the height of this laboratory. So now in practice, we determine the height of this laboratory from floor to the ceilings by using inverted staff method. So this is point A, and here this is our point A, okay? And our point B should locate above the sighting axis, and our point B will be located in here, in this point, and these ceilings, okay? So the first thing, I have to install my leveling instrument approximately half distance between point A and B. This is the approximately half distance. And the second, I have to level my leveling instrument by using the leveling screws and the circular air bubble. And the last, in the previous video practice, I already show you how to do this. So I've finished the leveling of my leveling instruments, and this is my staff or leveling rod. This is the barcode side, and this is the graduated side with the centimeters. And my assistant Otabek will help you to hold this staff vertically on point A. Okay. And the face of the staff should be in front of the my leveling instruments. Please hold the staff vertically as much as possible. Okay. Don't cover the face of the barcode with your hands. Okay, like this. Okay. So I see the eyepiece of the leveling instruments. I focus the staff by using the focusing screw. So now I got my first measurements, and my R1 is ready. R1 is equal to 1.519 meters. Okay. And now we have to bring our leveling stuff to point B. But now we have to do the stuff upside down. This is the upside down. Okay? The zero is start from here. Now we have to bring the leveling instrument on point P. And hold the leveling stuff like this. So now the leveling stuff on point B, upside down. So I have to rotate my leveling instrument toward to the stuff, and I see the eyepiece of the leveling instrument and focus this leveling rod by using the focusing the screw. So I got R2 measurement. It's equal 1.461 meter. So our R2 measurements is minus because we are using the inverted stuff method and we are holding the leveling stuff upside down, inverted. So now we can calculate the relative height point A and B, and this will be our height of our room, and this will be equal, or and H equal R 1.519 plus 1.461, and this will be 2.9, and now we have obtained the relative heat between A and B, and this will be our height of this room, and this is equal to 2.98 centimeters. This is almost 3 meters. In the building construction stages, we use inverted stuff method to determine the height of the rooms for each floor, just to check these heights meet which we planned, and discrepancy of these heights are within the acceptable tolerance, and this is one of the indicator to show the quality of the construction of the buildings. Thank you very much, and thank you for attention, and I hope you have learned what is the inverted stuff and when we use these methods. And of course, if you have any questions, please do not hesitate and give me your questions through the Telegram channel. Thank you very much.